And this question says solve the simultaneous equations. So normally when you see a set of simultaneous equations, either you have like a quadratic equation and a linear equation or both linear equations. In this case, we have simultaneous equations in the form of logs. So it might seem intimidating in like the first glance, but it's not that hard. So first we need to begin with getting rid of the log basically. So to get rid of the log, let's first name this equation 1 and this equation 2. So for equation 1, log of x plus y to the base of 3 equals to 2. What we're going to do is we're going to introduce a log on the right-hand side as well to further cancel it out. So 2 or like any whole number is basically being multiplied by 1 always. Any number is basically being multiplied by 1. So 1 is the same as log of any, like for example, a to the base of a. So the base and the number need to be the same. So since we have a base of 3 over here, so we can say that log of x plus y to the base of 3 is basically the same as 2 times log of 3 to the base of 3. This is the same as log of a to the base of a. Log 3 to the base of 3 will also equal to 1. Log a to the base of a would also equal to 1. So since our log has a base of 3, so introduce a log that has the same base to further simplify your equation. Now, once you've done that, another rule of logs is that we can bring the coefficient to the number and make it the power. So basically, we reverse it over here. So that's going to be log of x plus y to the base of 3 equals to log of 3 squared to the base of 3. This step makes it further easier for us to simplify the equation and cancel out the logs. Now, as you can see, there's a log on the left-hand side and the right-hand side, and these logs aren't being added or subtracted to anything. So we can cancel out the logs, and we're left with x plus y equals to 3 squared. Now, 3 squared is 9, so x plus y equals to 9. This is your first equation. Now, if we move on to the next one, we have 2 log x plus 1 to the base of 3 equals to log of y plus 2 to the base of 3. We're going to do the same thing. We're going to first move the coefficient and make it the power. So log of x plus 1 squared to the base of 3 equals to log of y plus 2 to the base of 3. Same thing, since the logs are like, separately present on both sides, we can cancel them out and we're left with x plus 1 whole squared equals to y plus 2. Remember, when you're canceling out the logs, the bases are also getting canceled out. So x plus 1 whole squared equals to y plus 2. This is your second equation. Now we're going to use these equations to further solve the question and find the value of x and y. So what we can do is that using the first equation, we can make y the subject. So it would be y equals to 9 minus x. Let's call this the third equation. What we're going to do is we're going to substitute the third equation in the second equation. So that would mean we have x plus 1 squared equals to 9 minus x plus 2. So x plus 1 squared equals to 11 minus x. Expand the bracket on the left-hand side. So that's going to be x squared plus 2x plus 1 equals to 11 minus x. Bring everything on one side. X squared plus 2x plus x plus 1 minus 11 equals to 0. So now x squared plus 3x minus 10 equals to 0. This is our quadratic equation. We're going to factorize this. So x squared plus 5x minus 2x minus 10 equals to 0. Between x squared and 5x, we have x common, so x plus 5 times x. And between 2x and negative 10, we have negative 2 common. So x plus 5 again comes in the bracket. So now between x and negative 2, x plus 5 is common. And x minus 2 comes in the second bracket. So one value of x is negative 5 and the other value is positive 2. So next, we need to find the corresponding values of y. To do that, we're going to substitute these x values into the first equation. So if I remove this part over here, at x equals to negative 5, your y will be 9 minus negative 5, which is equal to 14. And at x equals to positive 2, y is going to be 9 minus 2, and that is 7. So if you write it as coordinates, when x is negative 5, y is 14, and when x is 2, y is 7. This is your solution to this set of simultaneous equations.